Good morning, students. Let us next see now the next chapter of geometry, quadrilaterals. Now in this chapter let us study about the quadrilateral parallelogram, rectangles, square, rhombus, trapezium and midpoint theorem and the test of parallelogram. Now let us first recall about the following pairs about the angles and the sides of the quadrilateral. Now the figure which is shown here, it is the quadrilateral ABCD. Now the pairs of adjacent sides of this quadrilateral ABCD will be, there are 4 pairs of adjacent sides AB, BC, BC, CD, CD, AD and AD and AB. So these are the 4 pairs of adjacent sides. Then the pairs of adjacent angles are angle A, angle B, angle C, angle D and angle D and angle A. Then the pair of opposite sides are side AB, side CD, side AD, side BC. Then the pairs of opposite angles, only 2 pairs of opposite angles are there, angle A, angle C, angle B and angle D. Now let's recall about the types of quadrilateral and their properties. Now the first property is given here, both the pairs of opposite sides are parallel. Now there are 4 pairs of opposite sides. Now there are 4 pairs of opposite. Now there are 4 quadrilaterals which have both the pairs of opposite sides parallel: parallelogram, rhombus, rectangle and square. Now the properties of these 4 quadrilaterals are, the opposite sides are congruent and parallel, opposite angles are congruent and the diagonals bisect each other. Now the second property is all all angles are right angles. Now there are only 2 quadrilaterals, rectangle and the square, whose angles are right angles. Now the properties of these rectangles and square are, the opposite sides are parallel as well as congruent and the diagonals are congruent. Now third property, you see all sides are equal in length. Now there are only 2 quadrilaterals, that is rhombus and square, whose all the sides are equal in length. Now the properties are, opposite sides are parallel and congruent and diagonals are perpendicular bisector of each other. Then all angles are equal and all sides are equal. So we have only one quadrilateral square where all the sides are equal and angles are equal. And the properties is here, the diagonals are congruent and also they are perpendicular bisector of each other. Now only one pair of opposite sides is parallel, only trapezium has one pair of opposite side parallel. Now after this, let us see this definition of the parallelogram. A quadrilateral having both the pairs of opposite sides parallel is called as the parallelogram. Now here, so this is a figure of the parallelogram ABCD. So here we have AB parallel to CD, AB congruent to CD, AD parallel to BC, AD congruent to BC. Then angle A congruent to angle C, angle B congruent to angle D. So these are the opposite sides are also parallel as well as congruent and opposite angles are also congruent. Now let us see Theorem 1. Opposite sides and opposite angles of a parallelogram are congruent. Now let us see the next theorem. Opposite sides and opposite angles of the parallelogram are congruent. Now this is a quadrilateral ABCD. Here in given you will write down quadrilateral ABCD is a parallelogram. It means that side AB is parallel to side DC and side AD is parallel to side BC. Now see the second part of the theorem. Opposite angles of the parallelogram are congruent. This you have to prove. So you have to prove that this segment AD is congruent to segment BC, segment DC is congruent to segment AB, angle ADC is congruent to angle CBA, and angle DAB is congruent to angle BCD. Now construction here, draw diagonal AC. Now proof you see here, segment DC is parallel to segment AB and diagonal AC is the transversal. So angle DCA is congruent to angle BAC and angle, this is the alternate angles, and in triangle ADC and triangle CBA, angle DAC is congruent to angle BCA and angle DCA is congruent to angle BAC. So from equation 1 and 2, and segment AC is congruent to segment AC common side. Therefore, triangle ADC is congruent to triangle CBA by ASA test. Therefore, side AD is congruent to side BC, corresponding sides of the congruent triangles, and side DC is congruent to side AB, corresponding sides of the congruent triangles. So also angle ADC is congruent to angle CBA. Similarly, we can prove that angle DAB is congruent to angle BCD. So now the next theorem you see here, diagonals of the parallelogram bisect each other. Now here it is given quadrilateral PQRS is a parallelogram. Diagonal PR and diagonal QS intersect in point O. So now we have to prove that segment PO is congruent to segment RO and segment SO is congruent to segment QO. Now in triangle POS and triangle ROQ, angle OPS is congruent to angle ORQ, alternate angles. Side PS is congruent to side RQ, opposite sides of the parallelogram, and angle PSO is congruent to angle RQO, alternate angles. Therefore, triangle POS is congruent to triangle ROQ by ASA test. So segment PO is congruent to segment RO and segment SO is congruent to segment QO, corresponding sides of the congruent triangles. Then, so you have to remember these 4 things about the parallelogram. Adjacent angles of the parallelogram are supplementary, means their sum is equal to 180. Opposite sides of the parallelogram are congruent. Opposite angles of a parallelogram are congruent, and diagonals of the parallelogram bisect each other, means the point of intersection is the midpoint of both the diagonals. Now based on these 2 theorems and the properties, let us do the practice set. Now let us see practice set 5.1. Now quadrilateral XYZW is a parallelogram. Diagonals intersect at point O. Angle XYZ is equal to 135. Length OY is equal to 5 cm. To find out angle XWZ and angle YZW and length of WY. The quadrilateral XYZW is a parallelogram. Therefore, angle XYZ is equal to angle XWZ is equal to 135. Opposite angles of the parallelogram are congruent. Now, angle XYZ and angle YZW, their sum is equal to 180. Adjacent angles of the parallelogram are congruent, are supplementary. So now here you will get 135 plus angle YZW is equal to 180 degree. So YZW will be equal to 180 minus 135, that is 45 degree. Now length WY is equal to twice the length of OY. Diagonals of the parallelogram bisect each other. So 2 into 5, that is 10 centimeters. Now second one, quadrilateral ABCD is a parallelogram angle A is equal to 3x plus 12, angle B is equal to 2x minus 32 to find out x and the measure of angle C and measure of angle D. Now the proof is quadrilateral ABCD is a parallelogram. So measure of angle A plus measure of angle B is equal to 180. Adjacent angles of the parallelogram are supplementary. So 3x plus 12 plus 2x minus 32 is equal to 180. So 5x minus 20 is 180. 5x is equal to 180 plus 20, that is 200. So x will be equal to 40 degree. So measure of angle A equal to measure of angle C, that is equal to 3x plus 12, that is 3 into 40 plus 12. So 120 plus 12, that is 132. And measure of angle B equal to measure of angle D is equal to 2x minus 32. It is 2 into 40 minus 32, that is 80 minus 32 equal to 48 degree. So measure of angle A is equal to measure of angle C is 132 and measure of angle B equal to measure of angle D is equal to 48. Now perimeter of the parallelogram is 150 centimeters. One of its side is greater than the other side by 25 centimeter. Find the length of all the sides. Now let the length of smaller side be x and length of the larger side be x plus 25. Now in the figure you see ABCD is a parallelogram. So AB equal to CD is equal to x, BC equal to AD is equal to x plus 25. Now according to the given condition, x plus 25 plus x plus 25 is equal to 150. So 4x plus 50 equal to 150. 4x will be equal to 150 minus 50, that is 100. So x will be equal to 25. So AB equal to CD is equal to x is equal to 25 centimeters and BC is equal to AT is equal to 25 plus 25, that is 50 centimeter. Now if the ratio of the measures of two adjacent angles of the parallelogram is 1:2, find the measures of all angles of the parallelogram. Given ratio of the measure of angle A is to a measure of angle B is 1:2. To find measure of angle A, measure of angle B, measure of angle C and measure of angle D. Let the measure of angle A be x, measure of angle B is equal to 2x. So measure of angle A plus measure of angle B is 180. Adjacent angles of the parallelogram are supplementary. Then x plus 2x is equal to 180 degree. So 3x will be equal to 180 degree, x will be equal to 60. So measure of angle A is equal to x is equal to 60 degree and measure of angle B is equal to 2x is equal to 2 into 60 degree, that is 120 degree. So measure of angle A is equal to angle C is equal to 60 degree and measure of angle B equal to measure of angle D is equal to 120 degree. Opposite angles of the parallelogram are congruent. Now diagonals of the parallelogram intersect each other at point O. If AO equal to 5 and BO equal to 12, then prove that quadrilateral ABCD is a rhombus. Now quadrilateral ABCD is a parallelogram. Diagonals bisect at O. AO equal to 5, BO equal to 12. So you will get here in triangle ABO, AB square is equal to 13 square, that is 169. AO square plus BO square is equal to 5 square plus 12 square, that is 25 plus 144 is also equal to 169. Therefore, AB square is equal to AO square plus BO square. Therefore, angle AOB is equal to 90 degree by converse of Pythagoras theorem. So, diagonals of the parallelogram ABCD are perpendicular to each other. So, therefore, quadrilateral ABCD is a rhombus. So, if the diagonals of the rhombus parallelogram are perpendicular to each other, then it is a rhombus. Now, sixth one, here in figure quadrilateral PQRS and quadrilateral ABCR are parallelogram. Angle P equal to 110. Then find the measures of all angles of the quadrilateral ABCR. Now given PQRS and ABCR is a parallelogram. Angle P equal to 110 degree. To find measures of all angles of ABCR. Now quadrilateral PQRS is a parallelogram. Measure of angle P equal to measure of angle R equal to 110. Opposite angles of the parallelogram are congruent. Quadrilateral ABCR is a parallelogram. So measure of angle R is equal to measure of angle B is equal to 110. Opposite angles of the parallelogram are congruent. Now measure of angle B plus measure of angle C is equal to 180 degree. Adjacent angles of the parallelogram are supplementary. So 110 plus measure of angle C is 180. Measure of angle C is 180 minus 110, that is equal to 70 degree. Now 7th sum. Given quadrilateral ABCD is a parallelogram, AB equal to BE, to prove that BF is equal to CF. Quadrilateral ABCD is a parallelogram, so AB is congruent to CD. Opposite sides of the parallelogram are congruent. Now AB equal to BE, this is equation number 2, this is given. So from 1 and 2 we get DC equal to BF. In triangle BEC, BFE and triangle DCF, side DC is congruent to side BE. Angle BFE is congruent to angle DFC, opposite angles, and angle BEF is congruent to angle CDF, alternate angles. Therefore, triangle BEF is congruent to triangle DCF by SAA test, and so BF is congruent to CF, corresponding sides of the congruent triangles.